Hello, how are you? My name is Gülnur. I am the Research and Development and Quality Control Manager, and I'm going to be talking about a composite sector, but it says here it's 1 hour in the program, but no, in half an hour I'm going to complete my presentation. So let me give you a few words about my company. My company is METYX, and 15 years ago we were working on technical textiles and have entered to the composite world. In 4 different locations we provide production and service. We have 50 square meters of a production line, and these are our locations: Istanbul, Kozeta, and Tuzla, in Manisa, and in Hungary, in Başer. And our general head office is in Kozeta. It's the office that we just opened up a year ago. And our manufacturing premises are in Tuzla. There we are making traditional conventional textile implementation. We also have a research and development laboratory here. We also give also giving services for testing as well. In Manisa, we are producing technical fabrics. We are making new materials for the wind turbines. We are making molds as well for the composite sector. And we have also a sales office. And our other factory is in Kaposhvar. A technical fabric production is going on here, and we are also making some certain productions for different types of composites for wind turbines and for different projects. Taking a look at the picture, METYX has a distribution area for more than 30 countries. We can say that we are actually an international company. Let me tell you about our business fields. We are making fabric production, and on the other hand we are making vacuum materials. We're manufacturing vacuum materials as well. We are making kit production. When we are talking about kit, it means that these are actually the existing materials which are cut and put into the shape that we are looking for. We are making molds as well. We also have trainings. We are talking about generally the conventional and also the innovations in our sector. And besides, we are making the distribution of different types of productions that deal with composite sector. These are the sectors that we are dwelling in, like the maritime, wind energy, automotive, railroads, sports, construction, engineering, etc. And these are certificates for the quality systems: ISO 9001 environmental certificate, and we also have the OSAS certificate. We have also the ISO 14001 certificates, and laws and register is also a certificate that we received for maritime. And on the other side, I'm going to be talking about some certain applications that we do in the composite sector. I'm not going to talk about rocket science now, but even though the composite sector is growing fast, it's not that fast. Of course, there are some certain things that are easing our lives during production, and there are also certain materials that bring up novelties to our sectors. The first things that I would like to say here is the fast part materials with artisan. We are making fast part production techniques, and we are making preforms. We are working in clean areas. We can make a fast production. But when we talk about some certain boats which are quite big, or wind turbines, we can talk about days and hours. But in some sectors, particularly in the automotive sector, and you need to take 1 piece per second, for instance. In such sectors, unfortunately, the RTM and Infusion are not actually meeting our needs. So it's actually a dream to reduce the time to 1 minute. But there are also some certain issues about environmental pollution and etc., which we have to think about. And the automotive sector are rather using composite pieces for the environmental issues, and they are also very resistant to any type of a damage that can occur. So this is where we start thinking about the materials. Of course, we are using resins. The epoxy resin takes time for the curing, but the resin experts have brought up new formulations about epoxy, which is a good I would like to give a sample of BMW AG. They have started their production and they have initiated working on it. This is BMW spare part, composite spare part production picture. And another parameter for us is the preforms. The fabrics. Think about an RTM mold. You would like to make a production, and your pieces has a great shape, but you are going to cut the fabrics, and it is going to take a lot of time of you. The aim here is to save time. And so what are we doing here? Carbon fiber has been used here, and they all are put up over the other one, and they are pressed. So the materials are formed, and you put it into your mold. You're closing the mold, and you put the resin inside it. You make the resin flow inside it, and you receive a piece. There's a video that I would like to show you of the BMW composite piece parts production. This is a video that BMW has shot, where this is the phase of manufacturing the fabrics. Now the fabrics are cut, and the shape that has been as they're cutting, they are also giving the shape to the fabric. As seen, the preforms are put into the molds, and they're enclosing the mold and injecting the resin, and then this is how they receive the part. And most parts of the car is made of composite. This is an example for the RTM technique. Now we're trying to actually bring some certain solutions about this. We're not producing preforms, but we are producing fabrics that can form preforms, like in multi-axials, could be carbon or glass. We are covering the material with the fabrics, and we take the fabric and we put it into a hot press, and you can get the shape that you are looking for. So this is how you can get the preforms. But there's something that you need to take attention to. The resin that you're going to implement later on has to be in harmony with the resin that you're using with the adhesive that you're using with. Otherwise, due to the mechanical differences, some failures might occur, and that's the reason why we give some certain recommendations about what type of an adhesive to be used. One other thing is a cosmetic view of the parts. After carbon fiber entered into our lives, it has started to be used in high performance materials. But then they started to look for a carbon view as well. Many materials, even bags, are made in a carbon form, and since it is quite expensive, the stickers also regarded to that matter, and the sticker sector has seen it and started actually using it. But there might be some certain types of problematic issues, because there are some certain depth in the materials. In order to create a depth, you need to have a good form. It has to be flexible. It has to be thin so that it can be flexible. but it's an easy deformed product, and as soon as you touch it, it can actually be deformed. As soon as you cut it, it can be fragmented immediately. What is the solution here? Of course, some certain coverings are made, which are quite transparent. This is what we have done. A thermoplastic net has been put on the fabric. You can see the samples of it. It's a very flexible fabric. As soon as you put a certain tense, when you just grab it, you can see how it is flexible, and as soon as you leave it, it is back to its normal shape again. Particularly, non-conductive fire products became very important, and we have a regulation about this as well, which is also the EN European standards, with the EN 545. ISO, indeed, the ISO, it is actually different. A regulation that combines ISO and the DF standards together. So there's certain type of regulations and rules that we have to abide by. When we take a look to the standard, different levels are given for different areas. For trains, different tests are looked for, and the rails, some other things are being sought for. Now, this is also the METYX FS fire shield that we have manufactured here on the table. As you can see, these are the certificates. These are actually the test results that we received as we registered the certification. So there are 3 different hazardous levels: HL1, 2, and 3. HL1 is the lowest and HL3 is the highest threat. Of course, one of the most important parameter is the resin itself. The resin has to be non-conductive towards fire, so the resin manufacturers are working on it, gel coat as well. So the material over the gel coat should also be non-conductive as well. But the resins during production brings up some certain challenges, because the filling inside it, because of the filling inside it, the viscosity is very high, and it is not easy to actually dampen the fabric. There are some certain studies that are ongoing about it, but mechanically, for instance, the mats, the felts have been used. However, they are not actually giving the necessary performance. So RTN is also used. If you cannot, you should also think about the porosity of the fiber. And here, what can I suggest you? If you are preparing a thin piece, these thin pieces can catch easier fire. Thick ones are not, and that's the reason why they can pass the tests easily. So in this case, you need to increase the amount of glass. Even if, since there's a synthetic fiber, you need to think about actually increasing the quadriaxial, multi-axial glasses. And as a result of this, you can receive better results. This is all I can say about this matter. And the thermoplastic composites, these are the things that might not be a novelty for you perhaps, but it's a subject that we have started years ago. And thermoplastics resins have plenty of advantages. Taking a look to the work issues, it doesn't have any kind of a styrene inside it. It doesn't have any kind of environmental issue. It has plenty of advantages. But because because due to high melting, processing can be a little bit harder. And I'm going to be talking about how we can overcome it. There are so many places of application that, like in aerospace, the resins used in aerospace is different, in engineering is different, and cars it's different. Polypropylene, for instance, will be enough for cars, but in other products, in other sectors, the situation, the application must be different. For instance, in these pieces you are going to see it here. Enger and Kreismer 5 are actually recommending methods. Glass fiber and thermoplastic resins are involved in a certain plate. They are heated up in an infrared and are shaped in a mold, and with injection with the same polymer, they are injecting it to the polymer, and in the conjunction areas, which are quite deep, they create a hybrid production method. And of course, you have to prepare them previously. These are called thermoplastic prepregs. Excuse me for the technical failure here. Okay, what should we do? Okay, we can create a fiber. It's important to use a constant fiber. And how are we going to dampen it with resin? Because it's a more grift structure. And that's the reason why the resin cannot enter into the fabric. Since we cannot decrease the viscosity of resin, but we need to lessen the distance between the fiber and the lamination. So we have, let's say, a glass fiber fabric, then you have a thermoplastic structure, and again the fiber. Then if you do this, the resin can enter it. There's also another issue here where different types of methods are used. There's power impregnation as well, absorption like a dust. But there are electrolytic chargers that has been used for this, and different types of production lines have been started up to be used. In the film lamination, in the practical utilization, actually we can see that it is actually the polymer is wonderfully melting, but it cannot enter inside it, because when you just cut it and see how it is structured inside, we see that it is not actually proper as we are looking for. And on the other hand, you can press it and you heat it up, and within the mold you give the shape. So I told you before, the thing that you need to take attention to is whether the fibers have been dampened. How can we understand it? Let's say that we have created a plate, but inside it, the mattress and the fiber surface becomes very much important, like in the thermosites. How much the resins have to be quite proper with the material that has been used with it. Now here the resin has not been bounded to the fiber, but here it has been wonderfully bounded. And that is the reason why we need to find a fiber that is proper for the resin. And that's the reason why we need to talk with the resin producer. How to actually, how can we? Now if we take a look to the composite part, if there would be a film lamination, then we could see here air gaps, but there's a wonderful damping here. And glass fibers are here inside it, and there's no air bulbs at all. As for here, we have developed a product. I can give you an information about it. It's actually a product that you can see like a bobbin, and then it converts into a fabric. 60% glass fiber is involved, 40% is polypropylene. Later on, in the melting temperature of polypropylene, you can make pressing and you can give the shape. So organosheet, the thermoplastic plates are flat and rigid, so you can actually face some certain problems by putting it into the product itself. But here with molding, you just can give a shape with your manually. So here we can see some certain examples, like from yarns to the fabric and pressings. Okay, we are making a pressing here again, together with the foam product. So here we have a yarn which looks like a tube, and with braiding. You can also make a braiding here, and you can give the shape of a tube. There are different types of implementations that you can do and apply it for different structures. This is all I can talk about thermoplastics. But when we talk about infusion applications, infusion is something that has been used for years in composites. But now, of course, you know the wind turbines, wings are quite prominent to be produced. But we are now using the applications for infusion as well, not only in wind turbines, but also in the maritime vehicles like boats. But when the business is large and you have to use many different types of materials, this is a boat that has been produced. You need to think about the vacuuming. It has to be very homogeneous. When you have to distribute the air in a very homogeneous way. Our aim here is to dampen the fabric in time, in the proper time. So of course the materials that you are using is very much important. So what are we using here? There's something, a parameter that we cannot control, that is, we cannot actually arrange the resin amount. Of course, there's some certain types of ways that you can do it. With fiber, there is not much of problem of it, but of course you need to take care of how much amount of resin you're infusing. We also have some certain vacuum materials. A vacuum film, you also have different types of conjunctions, elements. You need vacuum felts, braiders. Now you need to control the amount of the resin. Normally we injected the resin itself found a path from the sides, but the middle of the fabric can be quite dry, and you cannot dampen the middle part of the fabric. These are some certain problems that we can face as well. Or let's say that it is very much dampened, but you want to give a little bit more of resin. Then the only thing you can do here is to actually capture the resin. And how to do it? We have a membrane. It's not actually, it's intervening the liquid to surpass, but we need to actually, the air has to infuse on the other side.
Our studies are continuing on. It is permitting the air, but it is not permitting the liquid, so it is encapsulating the liquid inside it, and it is possible to encapsulate the resin as much as you can and killing the relation with that. And this is a different application that we can provide for you, recommend you. And of course, natural fiber is something that we cannot escape, and all of the composites which are being supported by the natural fiber is very important. And 5 years ago, they have been introduced to the composite business, composite industry. We were having a French company in the past only. Whenever you go to a composite fair, an exhibition nowadays, many companies do have different methodologies, and they do have different types of resigns. And the most frequently used one is flex. It is possible to find it very easily. Normally it is being produced in Turkey. For the textile industry it is being used frequently, but it is not suitable for the composite industry. And just like the glass fiber or carbon-like structures, you are forming them and you're creating composite structures from these fibers, and there are a lot of companies doing that. Another alternative can be, of course, hemp, but there are some judicial factors. For example, sometimes the gendarme security forces are coming and asking you, what are you growing up? So it is sometimes being problematic to have hemp, to use hemp. What is the main purpose of using this? We would like to produce natural products. We do not want to do any harm. We would like to be environmental friendly. 1.4 grams / centimeter. When we look at it, glass fiber is 2.6. When you produce a material, of course, this flex structure is lighter than the glass fiber. In the laboratory, we have created barrettes, for example, and when you compare it with glass, when you compare the helmets, there's a huge difference between glass fiber and flex. And when you look at the resistance, it is almost the same, but you do have a lighter product, but the performance is being the same with the glass fiber. Just like the carbon structure, in many places they are using for cosmetic reasons, for example for the furnitures, when there is no need of strength and resistance. For the lightener chandeliers, for example, they're using for the structural pieces. In the automotive industry, it is finding a great place. We do have some products, weaving and single-sided fabrics, and plus minus 45 centigrade degrees of products. If you would like to have further information, you can come to our booth. And that's all I can say about natural composites. There is also a biocomposite structure. Yes, the fiber needs to be from natural sources, and its resin should be from the natural sources. Thermoplastic, for example, is being used. And also polylactic acid is widely being used, which are being taken starch, for example, which is being produced from starch. And we should not mix one thing. When we speak about biocomposites, there are two different things. One of them is the source of the material, which is a natural source, and the other one is the biopolluting type of material. I have attended a symposium a few years ago. It was an EU project, and many companies have joined it, and they have constructed a car. The fiber was natural, and there was transfer resins, and they have used polylactic acid. The main concept is the product will be recycling, will be composing in nature. In the end of the presentation, why I would like to use a recycling product, they could not respond it. If you are doing a biopolluting type of product, a biodegradable product, you should think why you are producing that product, because biodegradable feature is a very crucial feature, and thermoplastics can be used. I have spoken about glass and propylene type of fibers, and you're mixing polylactic acid and flax, and we do have such kind of samples. That's all I can say about biocomposites. For example, there is another application we have done. We have taken mat-like flax, and there's a water-based resin. We have dipped it in, and we have created a preparation, and you're shaping it when it is hot. I have shown it in the previous example. Inside the door panels, for the isolation reasons, it is possible to use it. And you can thicken it, and you can create a furniture out of this material. That's all I can tell. Thank you very much for listening.
Teşekkürler.